Let's look at lesson 3.2, which is looking at slope-intercept form and being able to identify the slope and y-intercept in the equation, and then using those to help us graph. So the first thing we need to do is look at slope-intercept form. Slope-intercept form is y equals mx plus b. This might be something you're familiar with from 8th grade. It's called slope-intercept form because it gives you the slope and the y-intercept. Slope-intercept form. And you'll see as we continue to move along in linear functions that the functions or the equations are named after what they give you, for the most part. So y equals mx plus b. M is the slope. It's the number in front of the x. Always. Right? Number in front of x. And the y-intercept is always the addition or subtraction. Okay. After, or it could come before, but it's not with the x. So I think that kind of helps me differentiate the two at some points. Now, what are the x and the y? Well, my x is my input. It's my independent variable. And my y is my output. It's my dependent variable. So just like we looked at in Unit 2, we can input a value, complete the rule, that is slope and y-intercept, right? Multiply by the slope and add the y-intercept. And it's going to give us our output, our dependent variable. So now that we know y equals mx plus b, and we've identified the parts, let's look at some equations and see if we can identify the slope and y-intercept. Something helpful that I like to do is write y equals mx plus b on top of my equations to help me identify. Okay. Now that I have them all lined up, I can see that my m is right over my 4, and 4 is in front of the x, so my slope must be 4. After is minus 2, so that must be my y-intercept. So it says minus 2. Okay, notice that the formula says plus b. Well, we can add a negative number. All right, so if it says minus 2, that just means my y-intercept is negative 2. We always take the sign in front. I'm going to skip over some of these and allow some of them to be done by you, and I'll show you them at the end. But I'm going to go over to the one that says y equals x. Okay, well, this one doesn't have anything with it. It has nothing in front of the x and nothing after. Okay, think back to what we talked about. If you just have an x and nothing in front of it, what number do you have in front of it? A 1. So what is your slope? Positive 1. Okay, well, there's nothing after it. Okay, well, if there's nothing after it, are you adding or subtracting anything? No. We could write this equation as y equals 1x plus 0. But we don't need to do that because adding 0 isn't going to change our problem. So we're just writing extra things. But our y-intercept is still 0. It would go through the origin if we were to graph it. Let's look at the one right next to it where it says y equals negative x minus 2. Okay, negative x. Okay, well, negative x, how many x's do we have? 1, right? There's a negative sign in front of it, but we can put that 1 in place, which means this time my slope is negative 1. Don't forget the sign in front of it. So if you see negative x, that means the slope is negative 1. My y-intercept is still after. Now with the x, it's negative 2. All right, now I'm going to jump down to these special ones that you see here, where it just says y equals 3. There's no x. And then x equals negative 2. There's no y. These are our special cases, and they highlight our horizontal and vertical lines. So if you see y equals 3, this is the equation for a horizontal line. If we don't have an x written on our equation, how many x's do we have? 0. we could write this equation as y equals 0x plus 3. And remember, the slope of horizontal lines is 0. This means that our y-intercept is 3. X equals negative 2. This must be the equation for a vertical line. And vertical lines don't have a slope. Right? That slope is undefined. It's straight up and down. And then most of the time, they don't have a y-intercept. Unless your vertical line is on the y-axis, right? You're not going to go through the y-axis. So for this situation, since it's x equals negative 2, your answer is going to be none. Okay, try those other 3 on your own and see if you can figure out what the slope and the y-intercept is. Remember, if it helps you to write y equals mx plus b above or below your line, or below your equation to write it, then you should. Now let's look at graphing. Now that we can identify slope and y-intercept, we're going to learn how to graph it, because graphing is super easy when you are given slope and y-intercept. You have a point to start at, that's the y-intercept, and then you know your rise over run. So if you have a point on the graph and you know the slope, you can graph the line. In the same way, if you know 2 points, you can plot those 2 points on the graph and find the slope, the distance, right? How you get the rise and then the run over to the other point, and then create the rest of your line. So in our first example, we have y equals 2x minus 4. 2 is in front of the x, so that's my slope, and negative 4 is my y-intercept. That was step 1. Step 2 is to graph the y-intercept. B is equal to negative 4, so I know that I'm going to have a point at 0, negative 4, because my y-intercept is always 0, comma, whatever the value is. So I'm going to go to my graph now and plot 0, comma, negative 4. From there, since I know the slope, I'm going to do rise over run. My slope is 2. I need to make that a fraction so I can do rise over run. I can make any whole number a fraction by putting it over 1. So that's going to be my slope. My rise will be 2. My run will be 1. Since my slope is positive, I know that my line is going to have to be positive. So I'm going to think about that and make sure that I do a rise, a positive rise, so up 2 and to the right 1, but I could also do 2 negative movements if I wanted to. So up 2, 1, 2, over 1, plot a point, and I can follow this trend all the way up my graph. Up 2, over 1. All the way up. Then I can draw a nice straight line through my points. That's close enough. And do some arrows to show that it is continuous. Now that I have that, I can identify my other key feature, my x-intercept. I can see that my line crosses through the x-axis at 2, 0. So that is my x-intercept. Now I can write it as it equals 2, or I can write it as an ordered pair. The same way I did with my y-intercept, where I said b equals negative 4, or 0, negative 4. I can do the same with my x-intercept. So I'm going to show both of them. Let's try one more, and then I'm going to leave the rest for you to try. I'm going to go with example number 3. I thought about number 4, where I'm given 2 points, but I know how to take 2 points and find the slope, right? I can either plot them on the graph and then find the rise over run, or I could use a table, a tiny table, and find the rise over run, the slope that way. It'll be up to you. And I've also noticed that example 5 and 6 are my special cases, so I'm going to go ahead and just do some yellow there to help you remember. Those are the special cases, and I should refer to this last page where I talked about my special cases when I'm looking to graph those. So example 3 says that my slope is negative 2/3. Oh, remember to take the sign. It's okay to have a fraction, right? That actually is helpful. I already have my rise over run. It's already a fraction. And then my y-intercept is positive 3. Remember, I can write this as 0, 3. So now, first step, graph the y-intercept, and then use my slope finding additional points. So 0, 3 is my y-intercept. Now I can do my rise over run, which is -2/3. So I'm going to go for my point, and since it says -2, I'm going to go down 2, and then I'm going to go to the right 3. Anytime I see a negative slope, that means that either my rise or my run will be negative, meaning I can either go down or I can go to the left if I want my run to be negative, but not both. If both of them are negative, that is the negative divided by negative is still a positive, so that would make a positive line. So if I want a negative slope, I can go up and then to the left, or I can go down and to the right. One movement will have to be negative, either my rise or my run. For this point, I've chosen to go down 2 and then to the right 3, but I can also, from that very same point, from my y-intercept, go up 2 and then to the left 3. Notice how both points fall in the line, right? They make a nice, pretty line. Just like that. Now this one, my y-intercept isn't graphed, but it looks like I'm going about halfway through right there. And if I were to use some math to find what my x-intercept was, I would see that my x-intercept is 4.5, going in between, right in between 4 and 5 there, or at a point 4.5, 0. Okay, so look over these, ask your teacher if you have questions, try to complete these other examples and the ones on the first page, and I will show you the answers in just a second. So here are your answers to the 3 equations, the slope and y-intercept for those. How'd you do? Okay, and here you have the other 4 graphs. Notice on example 4, I graphed my 2 points given, found the rise over run, and then used that to plot my other points. I actually found that the distance between those 2 points was a rise of 2 and a run of 4, which simplified to 1/2, which meant there was actually a point in between them. And then I used my information from there to find my x-intercept and my y-intercept. And then on example 2 and 3, I graphed. I changed my slope of -3 to a fraction, and then graphed it, and example 3, I already was given a fraction, so it was pretty easy to graph we did that one together. Example 5 and 6 were my special cases, right? Example 5, y equals 3 was a horizontal line through the y value of 3, and example 6 was a vertical line through the x value of -2. How'd you do? Let your teacher know if you have any questions and get started on that practice.